Well, we had homework on 1-1, 1-2, 1-3, because we've had 3 assignments so far. 1-1, 1-2, 1-3, and 1, yeah. 1-1, 1-2, 1-3. We haven't done 1-4 yet. We're starting it today. Now, the first thing we're talking about today is a polygon. Does anybody remember what the definition of a polygon is?
5 sides.
So does anybody know what poly means? Multi, because we use the word poly kind of as the prefix for multi, because polygon, it just means multiple. Now there is all of this here. Do not write all of this, because polygon means multi-sided. In geometry, a figure that lies in a plane is called a plane figure. Recall that a polygon is a closed plane figure formed by 3 or more line segments called sides. Each of these sides intersect exactly, so each side intersects exactly 2 sides at one vertex. Well, that no 2 sides with a common vertex are collinear. You can name a polygon by listing the vertices in consecutive order. So a polygon is what? A closed figure with 3 or more sides. It's a closed figure with 3 or more sides. That's all what a polygon is. It's a closed figure with 3 or more sides. Now, where 2 sides meet, we call a vertex. Where 2 or more sides meet is a vertex. So those points are called vertexes, and each where 2 points connect is called a side. Questions on this so far? And we use the vertices, the letters on the vertices, the points, to name it. Questions on this so far? Now, when we name it, we just pick one of the points and go around the figure. Huh? We good with this here? Now, there's different ways we can name the polygons based off their sides. Now, we'll fill this in together. Well, the smallest one we can have is 3 sides, yes? So what do you think we call a 3-sided figure?
Triangle.
A triangle. It's an angle that tries. Now the next one, so we could have 4 sides, and a 4-sided figure is called a quadrilateral. Now a square, no, I get square or rectangle every year. Now a square and rectangle are a specific type of quadrilateral. Yeah, it's very tempting to go quadrilateral.
I seriously thought like square 4 sides.
Yes. So square does have 4 sides, but it also has 4 right angles and 4 congruent sides. So it has more to it than just 4 sides. And we'll get into the definition of it, yes. Well, the next one we have is 5, yes?
Okay.
Stop sign, which is a pentagon. Pentagon, 5 sides. Yep, that's also why they call the pentagon
I need to go back.
pentagon. All right, guys. So 5 sides is a pentagon. The next one is going to be, well, 6 sides, which is a hexagon. Hexagon. 7 is heptagon. 8 is octagon. 9 is nonagon. And I'll wait. 10. Decagon. Dodeca. 12 is dodeca. Yep. 11 is undeca.
I feel like I'm in Spanish class all over.
11 is undecagon. They didn't put 11 on there, but I'll write in there it's undeca. There is, I think it's tre, T-R-E, decagon. But once we get past a certain amount, so we could say
What's 20?
n-sided, we can call it a n-gon. Whatever the number of sides is gone. So for 20, we could say 20. We can actually write 20. So for 20, we can say 20 dash gone, 20 gone. Y'all know what they call a polygon that's run away? Do you know what they call a polygon that ran away?
No.
It's in gone. It's in gone. It ran away, it's in gone. Any questions on this here? All right, guys. The next thing we're going to do is name polygons. So, yeah. So, we're going to start with J. So, whenever we name a polygon, we're going to name it by the number of sides and then by the vertices. So, we're going to start with J because we just need to pick one of the vertices to start with. So, we can say J. Now, we need to go left or right. So, J, C, D, E, F, G, H. And that's the name. Now, we can capitalize them. We can go the other way. We can say J. Oh. J, H, G, F, E, D, C. But again, we pick one vertex and pick a direction and just trace it all the way around. We just pick one of the vertices and trace it around, and that's one way we can name it.
So does it matter where we start
As long as we start at one of them and go around. The one that we can't do is we can't start at E, go E, J, F, C, G, H, D. That won't work. We can't just jump around. We've got to go. Yeah. Go around one way or the other. Now, how many sides does it have? 1, 2, 3, 4, 5, 6, 7. So 7 is a heptagon. So if we named it based off the number of sides, it would be a heptagon. Yes. Not the notes, but the review sheet.
Wait, so I have a question.
So you can use the review sheet, but you can't use your notes.
I have a question too.
Yes.
So do you want us to name it? Do you want us to do like heptagon and the whole letters, and that's how you want us to name it, or do you just want to do one of those?
It will, if it specifies just name it based off the number of sides, then you just need the number of sides, so it would be heptagon. Now, most likely the homework is going to say name the polygon based off the vertices, so that's our J, C, D, E, F, G, H, and number of sides, so you'll need both. So the long one is naming the vertices, name it based off the vertices. Sides would be heptagon. So for this next one, if we want to name it based off the vertices, we just need to pick, so S is our starting point. So we can say S, then what?
But if it just says like name the polygon, it doesn't really matter.
No.
Okay.
R, T, P, K, N, M, Q. So we just need to pick a vertex to start with and then go around the figure. Now, if we've named it based off the sides, how many sides do we have? 8, so it is octagon. Questions on this here? Any questions on this so far? So if it says name it based off the vertices, we're looking at the letters. If it says name it based off the number of sides, We're looking at octagon. If it says name the polygon based off the vertices and number of sides, we want both. We ready for the next part? So convex and concave. We're going to start with concave first. Now, a figure is considered concave if we extend one of the sides. So if we take one of the side lengths and extend it out, like we have the picture here, they extend it out like a line, and that line goes through the figure, it is concave. It's caving in. A polygon in which at least one line that contains a side of the polygon contains a point in the interior of the polygon. We extend the side. We draw a line pretty much on one of the sides, and if it cuts through the figure, it is concave. Essentially, it'd have a point that either juts in or juts out. It's going to be concave. Does that make sense? Yes? Mm-hmm. If we extend a side out, if we draw a line on one of the sides and it goes into the figure, it's concave. But essentially, when we extend one of the sides, we just keep drawing a line, extend it out, and it goes into the figure, it's concave. We good with this here? Anybody still writing? Yes, okay. We good? Yeah. All right, let's go back to convex. I'm going to reveal this here. A polygon in which no line that contains a side of the polygon contains a point in the interior of the polygon. So we have all this here. Don't, hold on, before you start writing everything down. So this is what it's saying. So really, I'm going to explain this for a little bit, then write it in a different way. So if we extend the sides out, we draw lines on them. None of those lines will go back into the figure, okay? So let me cover that back up. The way that I think of this is that convex is not because if we extend a side out and it goes through the center of it, goes into the polygon, it's concave. If I can't do that, and we'll look at some examples of this here. It's not, because it's either going to be convex or concave. If it's not one, it's the other, because it can only be one or the other. Any shape has to match is either convex or concave. So let's look at this first one here. So we're going to classify each polygon by the number of sides. So it's not talking about vertices. We actually don't have any vertices. So we're talking about number of sides. So we're going to make it. So this side here, if I draw a line and extend it out, does it go into the figure? So this here would be? Because it caves in. If we can draw a line on one of the sides and it goes into the figure, it's concave. If it doesn't, it's convex. So it has how many sides? 1, 2, 3. So it is a quadrilateral. You can write it.
Do you want it to say that's quadrilateral, or can we say it has 4 sides or something?
Quadrilateral would be the name. 4 sides. Now for B, if we extend any of these sides out,
No, it's concave. I mean, convex.
convex. So this is convex because it doesn't cave in. So 1, 2, 3, 4, 5, 6 is a hexagon. 6 is hexagon. Questions on this here? I think we might have 2 more. So if we look at the first one, so let's name it based off its sides.
Yeah.
1, 2,
Concave.
yes. So 5 is pentagon,
Are you okay?
and this would be concave, because really we can see one of the sides just caved in or caved out.
That one is hexagon and convex.
3, 4, 5, 6, 7. Heptagon. And it is or octagon is a stop sign, but there's not too many that actually are 7.
They're always usually about 8.
Yeah, they're 8, 3, 4. 7's an odd number. 7's an odd number.
What? Wait, what'd you say?
7's an odd number.
What do you mean it's an odd number?
Well, it is odd.
Oh, I thought you said God.
Yeah,
My bad.
it's an odd number, but it's also an odd number-sided figure. You don't normally see it. Questions? Yep. Questions on this here? All right. The next thing we're looking at is perimeter and area. So we'll look at perimeter first and then area next. Now, perimeter is just adding all of the side links together. If we find all the side links, we can add them together, and we get the perimeter. So the perimeter is really adding all the side links together. For a square, we have 4s, because all the side links of a square are the same. So we can multiply the number by 4, or we can just add those 4 links together. The same thing is true for a rectangle. Now they say they write perimeter as 2L plus 2W. Well, these 2 lengths are the same. These 2 widths are the same. So we're just adding the 2 widths together, adding the 2. For 2, or here.
Like, oh, those are the what?
Yeah, because here, this is all the 4 sides of its square are the same, yes?
Yeah, so it's 4.
Yeah. So 4 times that side length. So because side length plus side length plus side length plus side length, we got 4 of them, so we could rewrite it as 4 times the side length. For the area of a square,
So you just want us to say 4s?
and we can say 4s or 4 times that length, or we can just add them all together. Either one of those work. Because if one of the side lengths was 6, we could say 6 plus 6 plus 6 plus 6. Well, 6 plus 6 is 12, plus 6 is 18, plus 6 is 24. 4 times 6 is 24. It's the same thing. So we can add all the side lengths together, or we can use the formula. So either one of them works. Because again, perimeter is just adding all the side lengths together. The area formula for a rectangle is length times width. The area formula for a square is really length times width. But the length and width are the same. So we can say side times side, which is side squared. And the area formula for a triangle is 1/2 the base times the height. Any questions on this here? Let's when we start looking at them, it'll make more sense. Yes?
Is that bottom of it? Is that L or E?
L, length.
On the square.
Here?
The square. The rectangle, my bad. The rectangle. Sorry.
Go up.
Is that like an E or an L?
L. All these are L's length.
Oh, right.
Any other questions on this here? Now we're going to look at our first one here. Find the perimeter of triangle ABC with vertices -2, 3, 3, -3, and -2, -3.
Oh, shoot, we gotta do this?
Now,
Oh, wait, you have it.
I have it graphed up here. I think it's not included on your notes, but that's fine. We'll work with this together because for the most part, I will give you graph paper when we do this assignment. So as it's looking, we'll finish this up on Monday. I will give you graph paper so that you can graph it. And when you graph it, I would use the axioms. Now,
Definitely not. We're just too nice. We're suing.
I don't think you'd get a whole lot suing.
Stop throwing trash back. All right.
Thank you.
Thanks for your trash can.
Have a good one.
Bye, guys. Bye.
So, when you guys graph this on the homework, and I give y'all graph paper, try to stick to the grid itself, because as long as we see here, two of the sides of the triangle actually go along a grid, north, south, east, west, up, down, left, right. We can use the squares to count the units, because each square is going to be worth 1 unit. So looking at this here, well, we can see that there would be 1 unit, 2, 3, 4, 5, 6. So this has a length of 6. So we can count this direction, 1, 2, 3, 4. So we would add it, but we still need the third side.
Count the triangles.
Uh-oh. That's 6 triangles. No, it ain't. It's probably 7.
This is right.
So the distance formula, which we used the other day, because whenever it's not on a straight line, we have to use the distance formula. Now we actually could have used the distance formula from A to C, C to B, and B to A. We could use it for all 3 and got the lengths. Now from A to B, so we need the x value. So we need our -2 and 3. So we can say -2 minus 3 squared plus. Now we need the y values, which are 3 and -3. So we can say -3 minus 3 squared. Yeah. Okay. Yep.
It really does.
Now at this point here, we can type the whole thing into the calculator because we can do second square root parentheses. Bless you. -2 minus 3 close parentheses squared plus parentheses -3 minus 3 close parentheses squared, and hit enter. And it'll give us the answer. Now if we did this by hand, -2 minus 3 is going to be -5 squared. -3 minus 3 is going to be -6 squared. Well, 5 squared is 25. -6 squared is 36. And 25 plus 36 is 61. Square root of 61. And that's as simplified as it gets. Because the radical won't simplify, this is as far as it gets. Any questions on this here for finding the 3 sides of this triangle? Yes.
On the perimeter,
Uh-huh.
which is adding them all together.
Yes.
How would you add it?
And that's what we'll do next. Okay? We can do it right now. Any questions on how we found the length of each side? So our sides are 6 plus 5 plus the square root of 61. Now, if we want to add these all to get one number, we're going to have to change the square root of 61 into a decimal, because that's the only way we can add them together. Now, 6 plus 5 is what? We have 11 plus the square root of. That's an answer. Because if we want to leave it in radical form, that's as far as we can take it. If we want to convert it into a decimal, the button above the enter sign on those calculators where we tell it to calculate, the one that has 2 arrows, the button that looks like this, will approximate it into decimal form. 7.81. Either one of those will work. Now, for the book, and on the test, I will take either one. As long as it's the correct answer, I will take it. So if you give me 7.81, I will take it. If you give me 11 plus the square root of 61, and that is the same, I will take it. Especially with these here, if I have it written down as a decimal, I will check it to see if you got the right value. So I'll plug it in and calculate and see if it is the same. Yeah, that's fine. Because it's just rounding it to 2 decimals. Huh? Cal. Calculat. Yes. Any questions on this here?
Wait a second. Mine was buffering.
Okay. We will stop here for today. We are going to definitely finish this